Hi, I'm James Mahoney. This video is designed to supplement an in-person class. This video offers some tips on working in Unity as a designer or 3D modeler. We'll start with the very basics, and later videos will show more advanced things. Unity is an unbelievable tool for creating amazing things. I've been doing digital art since the 1980s, and this tool is a dream come true. However, it does take a lot of effort to make truly beautiful things with it. Let's start with process. Open up Maya and create a project and set Maya to that project as you've done in CS22. Create a new Universal Render Pipeline Unity project as well. We'll be using this render pipeline in the class. The workflow from Maya to Unity is pretty sweet actually. The only really tricky thing is that Unity is a real-time renderer and so requires a slightly different approach to modeling. It's generally less forgiving. Beyond that, it's a bit tricky to make sure you're working to scale. Let's set that up. In Maya, create a cube, 1 Maya unit by 1 Maya unit. Snap the pivot point to the center bottom face and set that to the origin. Hit D to move the pivot point, W for the move tool, and hold V to snap to the vertex. If you select the Y-axis and middle mouse click to snap the pivot to the bottom of the quad, it won't go to one of the vertices. It'll just go right to that level. Hit Q to get out of pivot mode. W for move again. Type 000 in the absolute transform to put that at the origin. Freeze transformations and delete history. Always remember to do this before exporting to Unity. Always remember that. Under File, in the top menu, find Send to Unity and Set Unity Project. Select your active Unity project. And now, with your cube selected, choose File, Send to Unity, Selection. Create a new folder called Models, if there isn't one already. In the folder, save your object with the name Maya 1 by 1. In your Unity file, create a plane and name it Ground, and right-click on its transform bar in the inspector and choose Reset. Create a folder in your Projects panel under Assets called Materials, if there isn't one already, and create a new material, white, say, and assign that to the plane. Create a new game object, 3D object. Name it Unity 1 by 1. Reset its transform as well. This should set the scale to 1 by 1 by 1. Assign a material to it, and then drag it into your prefabs folder. Create one of those folders if you need to. Delete the original, and now drag this new prefab onto the ground plane. Scale the ground plane as you want. The new prefab should sit right on the plane. Now find your Maya 1 by 1 in the Models folder and drag that in on top of the plane as well. You'll notice that it is 2 orders of magnitude too small, and you have to resolve this. And there's several ways to do it. You can change your units in Maya, which seems like the right thing to do, but in the old days anyway, this would cause a lot of strange behavior in Maya. You can also adjust the scale at export, but that has some problems too. Here's what I recommend for a foolproof way to get scale. Work in Maya such that 1 Maya unit is 1 Unity unit, which is 1 meter, and export as shown. In Unity, select the model in the projects folder. In the inspector, you'll see some tab-like boxes at the top. These allow you to adjust the imported object. With model selected, you'll see a scale factor of 1. You could type in 100 there, but instead, I uncheck the Convert Units box and hit Apply. It's pretty simple, and I've never seen anything strange using this method. Scale is very, very important. It's important for models as well as textures. With this in mind, I really insist that all modeling environments have a human-sized scale figure to make judgments against. It's okay if the scale figure is 2 meters, maybe a bit tall, but 1.7 or 1.8 meters high would be better. It'll match the player controller, which we'll be seeing a lot of in this class. In Maya, create a new cube and name it human scale or something. Set the dimensions to be 1.75 tall and about 0.2 in width and depth. Set the pivot point to the base again and place it at the origin. It's good to practice that. Freeze transformations, delete history, and export to Unity. Create a prefab of this thing. And in the inspector, don't forget to uncheck Convert Units. Feel free to make a fancier one where there's a sphere at the top or anything like that, but make sure that the total height is about 1.75 units. There's a few other things to be aware of when using Maya for working in Unity. First off, you need to realize that the smooth preview will not export to Unity. If you take a cube and you hit the 3 key and it looks smooth, it's going to come out as a cube. It's tempting to keep your models low poly, but this is trickier than it seems, as curved surfaces with low geometry resolution will often create artifacts. These can often be fixed in the import dialog by calculating normals manually and trying out some options here, but this will vary from model to model, and like I said, it's a bit trickier. It's easier to have a bit more geometry for a nice look. The key is just enough geometry, but not more than you need. You can still get a crisp look by carefully applying smoothing groups or even just smoothing, having sharp and smooth lines or edges. Select all the edges and make them soft. Then select the crisp edges and make them hard. You can use display, polygons, show hard surface, hard soft edges to see what you're doing. Study the polygon mesh and make sure you have enough resolution but not too much. You generally want to avoid long, thin triangles that are generated from long, thin quads or end caps, as these can sometimes create artifacts for a real-time renderer. You can see that effect in the engine tubes of this demo ship. It needs more geometry. An easy way to fix that is with a few more edge loops. And try to find the minimum geometry to get a clean look. UV mapping is critical for real-time rendering, in most cases anyway. You should know how to UV unwrap from CS22, but give it some thought. Do you want a material with variable tiling? Maybe you unwrap that as a separate UV map and material. Do you want something to be symmetrical or the exact same texture but upside down? If so, do that for your UV mapping. In this case, the bottom part of the ship is to be tiled, and so it has its own material and UV map. The engine tubes are identical, so they can overlap. I could have done just half the upper shell and overlapped that too, since it's pretty symmetrical. But I wasn't sure if I wanted it to be symmetrical. Maybe if it's asymmetrical, you can have things like dirt and grunge, for example. But here's the thing. Unity wants to bake light maps using these UV maps. A map to capture diffuse reflections and subtle shading that's too expensive to calculate at runtime. And for that, all your UV polygons must never overlap. But it's okay, as this is a common thing, and Unity will allow you to have 2 UV maps for an object. Notice how the bottom hull can overlap because it's a completely different material. The other parts will share a material and map, and this is called an atlas. And in Unity, this is commonly used for sometimes multiple objects, all sharing the same input texture. Use image, UV, snapshot in the UV editor to create an image that you can then open up in Photoshop to create your own texture maps. Now let's create a second UV set for the lighting information, for the light maps. You can open up a UV set editor in Maya and create a new set. Then you can distribute your shells so that they don't overlap in that UV map. Unity will assume that UV set 2 is for light mapping. For more information and tips and tricks for UV unwrapping, there is a document linked in the syllabus. Walk through that a couple times and you can do pretty much anything. With regards to materials, you can find the materials in the import dialog here and hit the extract button to grab materials from Maya. But I don't recommend that because Unity materials and Maya materials can be really different and they won't behave properly in many cases. So for this class, and in general really, I recommend using materials in Maya to indicate which things are which material, wood versus metal, for example, or repeated tile versus not repeating tiles, that kind of thing. But then in Unity, don't extract the materials. Instead, create your own in Unity or Substance Painter and drag those into the material slots in Unity. Unity will have access to the different material slots. I recommend everyone learn how to make custom material maps in Photoshop. I know that you might prefer using Substance Painter or something like that, and that's fine, but learn this as well, because then you will have a deeper understanding, which will lead to much greater flexibility when creating assets for use in Unity. Start with the UV snapshot created in Maya. If it does not have alpha, you can put that layer on a multiply blend mode and with a white background at the very bottom, and then you can see the UV map. So you can see as you're creating these maps and painting where they're going to end up on the model. You can then paint or assemble images in any way you want in Photoshop. A great shortcut for working with custom-made material maps is to include the Photoshop PSD file that you're using directly in the Images folder in your Unity project. Then in Photoshop, you can create folders or layers, but folders will force a full image instead of being cropped based on transparency. So folders might be the best thing to do. Name your folders as a file name like maintexture.png. By using a file name with an extension that's an image, you can then go and find under File, Generate, you can turn on Image Assets. Now this Photoshop file will create a subfolder and will keep those images up to date. So any changes in the Photoshop file will automatically update in the Unity project folder right away. And this makes your workflow super fast. In this simple ship example, there are 3 images. One is the main ship texture. The other is the main ship metallic map. So this is a black and white image that can be used to indicate how metallic each part of the ship is. White would say this part is very metallic. Black says it's not that metallic. And a third image is used as a tile for the bottom, and we're going to repeat that to create a tiled look. It's a separate material, so it's easy to tile this with some larger number to create the look you want. This is a super simple example, but demonstrates how you can custom make images and use them to define materials in Unity. This is most useful for non-photorealistic images or a stylized look, as these textures, of course, can be anything. They can be watercolor, painted, photographs, collage, whatever you want to do. Okay, I think that's probably pretty good for now. I'll see you later.